We can go ahead and get started. Hello, everyone. Welcome. Thank you for joining our weekly Lunch and Learn CEU. We're excited to present to you today. My name is Amber. We're with Precision Property Measurements. My colleague Justin Yoder, who some of you are familiar with, will be presenting the course today. Before we get started, I'd like to cover just some administrative items. If you would like AIA Learning Unit credit for this course, please put your name, your email address associated with your AIA account, and your AIA member number in the chat. I'll be taking attendance and passing it off to Pam at AIA Potomac Valley to make sure that she can disperse the credits to you all. So please put those in the chat, and I'll continue to mention reminders in the chat for you to do that as well. And without further ado, I'll pass it off to Justin. And thank you again, everyone.
Awesome. Thank you, Amber. And hello, everyone. I'm going to, Amber, can you actually enable screen sharing, please?
Oh, I sure can. My apologies.
Give us just a second to get this worked out, everybody.
Okay, I believe I changed it now.
All right. Let's go. We're going to do. All right, one more second here. While we're doing that, I'm also going to apologize in advance. If you see me squinting a lot, or if you see me pausing to look at my screen, I'm having some issues with my eyes, and so I'm gonna push through, but just wanted to give you a heads up that I'm struggling a little bit today. So, all right. So, can all of you see my screen now? All right. Awesome. Thank you. Hello, everyone. I'm glad you could join us for our, I think it's actually more than second, AIA Potomac Valley webinar on as-builts. For those of you joining us for the first time, welcome. And I hope you learned something new to improve your current as-built processes. And if this is your second or more time, welcome back. Thank you for joining us again to hear what we have to say today. There are going to be some new nuggets. We have revised our CEU a little bit, so there should be some new stuff even for those of you repeat attendees. And why is my screen not advancing? There we go. All right, my name is Justin Yoder, and I am the Regional Director of our Mid-Atlantic region. For more than 2 decades, PPM has been a reliable source for as-built surveys for architects and designers and a bunch of other AEC professionals all over the country. As time has passed, the way we gather data on site for as-builts has undergone significant changes, as I'm sure all of you have seen. And in this presentation, we'll take you through methods of data collection and how to draft as-built plans. Here are a little bit of particulars for important course information that I need to share with you. Here are the course objectives. And at the end of this course, you will know how to create as-built plans for any project type, recognize the various laser scanning technologies used for collecting data on site, understand the role that point clouds play in displaying data in a usable form, and finally, you will become familiar with the techniques for drafting and modeling as-builts in AutoCAD and Revit. Today, we'll be covering best practices for surveying, drafting, and modeling of as-built plans. We will cover what are as-built plans, processes of gathering on-site data, and how to create an as-built set. So what are as-built plans? In simpler terms, as-built plans are drawings or models that accurately present the existing dimensions and conditions of a building. And now, before we dive deeper into our presentation, I'd like to mention that today we'll focus on the production of as-built plans in 3D Revit and 2D CAD files. However, it's important to note that there are numerous other design softwares available for drafting as-built plans, And whatever you choose, there'll be tips for you within our presentation today. All right, so without further ado, there's going to be a few polls throughout the education unit here today. We just like to kind of gather information and really know who we're talking to today. So if you can type your answers into the chat, Amber will help me collect that, and we can kind of go through them and see what we have and talk about them. So type it in. You can either write the full thing or just write the letter. A, I create them myself. B, I have an internal team, or C, I partner with an as-built professional. Just going to give you all a moment to do that. See some A and Bs. C, lots of A's. C. Well, for those of you that I see, that I know that your C is us, thank you. I appreciate that. For those of you doing it yourself or having an internal team, hopefully you can see the benefits of not only using laser scanning or other technologies, but also the benefits of potentially using a third-party as-built provider throughout the presentation. But no matter which way you go, hopefully you'll learn something that'll help you out. All right, gonna keep going here. For some reason, my computer is being a little laggy. All right, so we're gonna start talking now about collecting the data on site. Now we're going to talk about those various methods of collecting the data on site and how to generate it. The first one is traditional methods. Now, as you probably all know, traditional method basically is sketching, and all of you are probably familiar with that. So we're gonna keep our time on that particular section fairly brief. And I'm sure we all know how to sketch, so we won't go deep into it. But a couple of quick notes. Remember that sketching does not need to be to scale. Just make sure that you have enough room to take down the dimensions and some notes as you're going through sketching your as-builts. And getting all your sketching done before you start taking dimensions is a huge help on site as well. The better the sketch, the easier the measurements. Plan ahead to get your heights or your z-axis measurements and sketch out any of your details or ornamentation that you need based on what your degree of precision is. And we'll talk a little bit more about that later as well. The best way to start measuring your plan view is to start by taking measurements of all the exterior faces. When taking those measurements and those dimensions, you want to make sure to check that all your X and Y dimensions match up. So sometimes this can be tricky when you have curved walls or lots of jogs or walls that are not at a 90-degree angle, but by adding them up and comparing them to the other X or Y dimensions helps to verify that you have measured correctly. Everybody has a little bit different view of degree of accuracy, but generally if they're within 1 inch or 1 to 2 inches side to side, that's usually pretty close for most properties. You can save some time by using tracing paper to take down different dimensions. So just as you can see on the image on the screen, you simply add more information or symbols to the plans using the different colored pens and the different layers of trace paper. For this, I will highly recommend you get those sketch pads that come with paper and vellum so that you don't have to stress about carrying multiple items on site. And we all know how uncomfortable that can be to carry a lot of stuff around as you're trying to measure, but especially if the site is hard to navigate or does not have ideal site conditions. And this will conclude the traditional methods section of the as-builts. Again, we all know that we all are pretty good at the old traditional methods, so we're going to move on from there. All right, so we're going to move into the advanced section where we'll cover mobile and terrestrial LiDAR scanners. Updating or even replacing a proven method for doing something to utilize the newest technology isn't an easy decision to make, no matter what industry you're in. So the first step you take is often the most important. And the rest is hard work and diligence to really make sure that it's working for you. So even though it may be difficult to transition, making the change to laser scanning as a survey method provides you with fast data acquisition. It's more accurate than any measurement that can be taken by hand. It also reduces the odds of human error dramatically in the field as a result. This technology can be purchased, rented, or contracted. So there are different levels of investment in the technology for you. And it's a thorough solution. It allows surveyors to gather more data than is actually needed to complete most projects for the as-built portion. It provides a digital twin, which we'll see a little bit later, to pull additional data down the line if the project ever needs to be revisited or additions need to be made to the scope of work. So what does LiDAR mean? We hear about it in the news and articles about autonomous vehicles and robots, and it's the same technology we use to get survey data, but it stems from a word that's radar, R-A-D-A-R, which stands for radio detection and ranging, and that's a much older technology, but it works in much the same way. LiDAR, on the other hand, stands for light detection and ranging. It's a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. Each one of those illuminations can be considered a single measurement, and each single measurement is logged, and throughout the course of the scan, millions of measurements are taken in all directions. So I'm sure all of you have used a laser disto in some variety at this point. It's millions of those with a single device. All right, so when we need very accurate measurements or a lot of intricate detail captured for historical projects, structural or engineering analysis, or prefabrication projects, we go to our favorite terrestrial scanner, which is the Leica RTC 360. Even though this scanner needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short, especially compared to other terrestrial scanners, and making it the fastest terrestrial option on the market currently. The iPad app that is used with it also helps make sure you can check your point clouds before leaving the job site. And the RTC 360 is extremely precise and gathers so much data that point cloud files can be well over 500 gigabytes. And whether we use the onboard camera to make a color point cloud or not, we always get very dense, very accurate data that allows us to draft and model ornamental detail, pipe valves, and other intricate details with precision. Because our final data is made up of hundreds or even thousands of scans performed with this scanner, it makes it ideal for the starting and stopping, sometimes required in busy spaces like hotels, multifamily, shopping malls, and industrial spaces. And in the next slide, we'll see a short video of a scan taken with this scanner. While our other scanners can be moved while they are operating, the RTC 360 needs to be placed in multiple positions all over the building or property to get a full set of measurements for our plans. Each red dot you see here is a place where we strategically positioned the scanner to gather the black and white data you see here. And even though we did not use the camera for this data, you can see how much detail we can get using the black and white measurements gathered. Each black and white point or pixel is a representation of an actual laser measurement, accurate down to less than 2 millimeters. This means that this entire 3D picture you're looking at is dimensionally accurate. And we use this data to help an architect identify floor sagging, wall sagging, and other structural issues before a major remodel of this 100-plus-year-old casino in Colorado. The Hotel del Coronado in San Diego County, California, has partnered with us twice for renovations over the years. And the first project was an AutoCAD interiors only, which was more for hospitality renovation purposes. The job ran like a typical job of ours, and the second time they partnered with us, they requested Revit for their exteriors only, which is what you see here. This was done with the purpose of doing wholesale renovation of the exterior while preserving its historic look intact. Our surveyor in this project used the RTC 360 at this site and scanned every single room exterior across the 96,000 square foot property. We spent a total of 656 hours drafting and modeling this project, and the work was spread among several of our experts in-house. And mobile scanners, we're going to switch to talking about mobile scanners. They're a different type of scanner that we use daily. And to discuss the differences between terrestrial and mobile scanners, let's look at two of the mobile scanners that we use most often, the GeoSlam Zeb Horizon and the GeoSlam Zeb Revo. Excuse me one second, I got a cough. Mobile scanners are handheld and quite easy to use. Using a mobile scanner is preferable if you need accuracy and your time on site is limited. Since most individual scans take only 15 to 45 minutes, we recommend you process that scan on site to check your results before you leave. Once the scan is complete, you need to use the SLAM algorithm software, which interprets all of the measurements and movement data from the scanner to produce the 3D point cloud. And after the 3D point cloud has been created, you need to review the point cloud to ensure accuracy. Most errors that occur when scanning can be spotted quickly. And as you will see in the coming slides, actions such as rescanning can be taken to ensure overall accuracy of your project after that. This is what a point cloud data will look like from the Revo or the Horizon in plan view. You can see that even though there is no photo-based colorization like in the RTC data, with the points, these points are colored on a height ramp, where points at different heights are shown as different colors on a spectrum, which you can see on the left, red is lower and blue is higher. Coloring the points this way makes it easier to see important features in the point cloud, even without the photo colorization. All right, so as I said earlier, we have two types of mobile scanners. The Horizon, as shown in this slide, collects 300,000 points per second with a 6mm level accuracy. You can't beat this level of accuracy with the traditional method, and especially on large projects. It also covers a range of 100 meters, and you can scan up to 50,000 square feet of space in just a few hours. You can pretty much use this to scan anything that's visible, of course, and we have used this to scan single family, commercial projects, restaurants, retail, and warehouses. We have also used it for other rehabilitation projects like the Apollo Mural Restoration in South Beach, California, and a few historic renovation projects in the DC and Annapolis areas as well. This is a very expensive tool though, so you need to handle it with caution and care. And here's an example of a project we scanned using the Horizon mobile scanner. It's a 9,000 square foot single family residential house located in DC. It's a beautiful property that was built in 1836. And as you can imagine, there are no as-builts to reference prior to us doing as-builts on this property. So the client requested our remodeling package, which includes floor plans, roof plans, and exterior elevations, and still photos. This project was modeled in AutoCAD, and it took about 36 hours to completely draft it from the point cloud data. The total time spent on site to survey the property was roughly 6 hours. And just imagine how long and difficult it would have been if you had to do that using only tape measures and laser distos and sketching. And this scanner here in this image is the Revo. It is a slightly smaller in size than the Horizon. And just like the Horizon, it reduces the scanning time by about 90%. This scanner collects roughly 43,000 points per second with a similar 6mm level accuracy to the Horizon. And again, you can scan just about anything with this scanner. The only thing to note is that the Revo scanner collects fewer points than the Horizon. So for larger projects, you may need to merge more point cloud data or just scan more individual scans and merge them to begin with. And again, like the horizon, you can scan up to 50,000 square feet in a few hours, but that does vary by construction type and density of the property and the layout. Here you will see a example of a mixed use project we scanned using the Revo. It's a 27,000 square foot building located in Seattle. The client requested floor plans, roof plans, exterior elevations, reflected ceiling plans, and interior elevations. This image is what the RCP looked like. And as you can tell, it was a very dense project with lots of information. It took us about 8 hours to scan and about 36 and a half hours to draft the project in AutoCAD. So now that we have explored the tools used for the advanced method of data collection, let's take a quick look at the point cloud data itself. Reviewing your data well before attempting to create a set of as-builts from a point cloud is a must. If there are any kinds of errors with your point cloud, which as we mentioned before do happen, you want to make sure you catch that before you start drafting. And once your scan has processed, you'll need to review the output. Did you cover all the areas? Oftentimes, people have very well hidden closets and secret rooms and well interior design spaces that hide spaces. And you need to check to make sure that you've captured all those. Sometimes you find some dead spots in the scan, and those are sometimes there for a purpose, and sometimes spaces that you need to go back and capture. And did you cover all the areas? Are there any flaws or errors? Ensure there's no drifting. In the next slide here, you can see there is some drifting in the lower right. It can happen when the software has trouble putting all the points together. Sometimes it's due to not being able to traverse all the way around a building. That I'm pretty sure is the case in this one. If it does occur, then you can try some reprocessing options with the SLAM software, or simply scan the structure again. Drifting includes reflection noise, other data noise, needing to use other devices for control on a larger building, internal scanner errors, mirrors reflecting data, and duplicate data. It's important to keep an eye out for multiple types of drifting inside and outside of the building and know what you're looking at. When scanning attics, foundations, large sites, or multiple level structures, you may run into issues getting all your data to fit together. Areas that are hard to access or have lots of reflective surfaces or have fewer unique features like office hallways or open and empty spaces can all pose a challenge. Processing requires all areas have data connecting one area to the others so they can be properly glued or stitched together. So you want to have overlap. Mirrors, moving objects, etc., can also trick the process and therefore give you bad output. The screenshot you see here is of a multi-level structure and is a space with fewer unique features, and additionally is an open and empty space. And it did actually pose a challenge while on site scanning this property. Scanning those attics and foundations, large sites, or multi-level structures can pose data integration challenges as well. So difficult to reach areas, reflective surfaces, and featureless spaces like these office hallways and whatnot can be particularly problematic. Most scanners have a range of hundreds of feet, which can produce a lot of data outside your project that you don't need. You may need to clip or crop your point cloud to reduce the file size by getting rid of that unwanted data. For example, with the horizon, scanning on a roof, you could capture buildings, a long ways away and can really hamper your ability to import it into AutoCAD later or Revit. If you must produce multiple point clouds for a large or complex project, it will be important to get comfortable with point cloud software that will allow you to merge or register your clouds and more easily manage your data. And since much like the traditional method of sketching and measuring properly, scanning a structure takes lots of practice to do correctly and efficiently. Once you are practiced with scanning and you know what to look for when errors may have occurred, you will have the most reliable version of the data you can gather in the field. You can be confident that the as-builts you create will be fully accurate and ensure a smooth and safe renovation as it progresses. So Now we're going to talk a little bit about levels of detail and scope, and what the terrestrial and mobile scanners can do, what they're capable of, and also we want to chat about what that means for your scope and ultimately impacts to your time on site, time drafting, and fees if you're hiring a third party to do the scanning and modeling or drafting. All of the above, ornamental detail, historic details, global accuracy, multiple tenants, multifamily, mixed use spaces, all of those might be some reasons that a terrestrial scanner may be a better option. But let's also talk a bit about what that looks like in the various clouds, time on site, and information that we'll need to make an informed decision on your proposal and a path to getting your as-builts. Ornamental detail can mean a very fine granular level of information or just certain parameters that can only be seen with the RGB data or with a denser point cloud. Historic details such as the ones below in the RTC image may be critical to replicate, or there may be other detail that wouldn't show up in the mobile scanners that might show up with the RGB data as well. Global accuracy comes into play a lot with the larger and more complex projects. If you have multiple tenant spaces or condo units, et cetera, that you're scanning, the RTC and other terrestrial scanners register that and allow the global accuracy to be more accurate. And as you, as you can see from the lower right, the amount of information captured here is between the two levels of scanners above. The RTC in the lower left is what captured that data. It has more points, a finer level of detail, and the upper right is sufficient data for our typical floor plans for the average home or commercial project, and that was captured with ZebRevo. So if you need ornamental details such as a keystone, fluting, corbels, or other architectural elements or historic detail, we may need to use a more granular level of detail scanner. And yet most projects, it's sufficient to provide an as-built drawing based on a cloud from one of the GeoSLAM products. So what does that mean for your deliverable? Our typical level of detail is LOD 200. And as you can see here, the elevation drawn with the LOD 200 level of detail, it can be produced by hand or with any scanner, but as for type of scanner, the Revo would or could be a good choice for this property. Items that would be covered would be the main structure of the house, the main lines of windows, fascia, etc., as shown, but you do not see the finer lines or fluting on this particular elevation. This one, on the other hand, is an elevation based on LOD level 250. The same information as what you saw on the last elevation at the core, but a few more lines, a little more detail, etc. So what does that mean for your scope? It means knowing what your needs are, and that will help us or other third party or even internal staff better meet your expectations, but it can also affect time on site, time drafting, and thus fee. Mobile scanners will likely be less time on site overall to capture any of this information, unless you have a lot of scans that require global accuracy, and then what you spend in scanning time, you'll gain back in less complications in the drafting and modeling process. Terrestrial scanners can take hours, if not days longer on site. So where clients or occupants can't provide extended access, the mobile may still be an option. We all can agree that time equals money in many different facets. So the more time that needs to be invested, the higher the fee can likely be. But on those projects, you'll still substantially save time over hand measuring and improve the accuracy. The more we know and understand, the higher the likelihood a third-party laser scanner, AutoCAD and BIM company will be able to deliver a project that you will be happy with. As you can see from this slide, working from the point cloud allows us to take reasonably accurate point cloud information and translate it into 2D CAD or 3D BIM information. However, we as built surveyors and drafters have to make judgment calls and do not know what is important now, nor what may come up as critical information later. The points can build up in a scan, meaning similar to spraying a can of spray paint or something, it builds up. So that can affect the level of accuracy as well, depending on capturing too much point cloud information. So let's see. What does that mean? While we take verifying measurements, we know the bones of the scan and the model and drawings will be accurate, yet there can be variations based on angled or skewed walls, assumptions on interior wall accuracy versus global accuracy, etc. And so knowing what is most important in your scope and standards may help the third-party drafter, surveyor, or even your internal staff keep those judgment calls aligned with yours. Different scanners will allow differing options for being able to see that information in the cloud as you slice and or cut the cloud to model or draft over top of it. But it allows the ability at any given time to reassess the site. Um, but going back to the site to reassess it usually isn't needed. Here's a brief video of the transition between using a Leica scanner showing the point cloud and the subsequent model. A few points to remember. Your scope and level of detail can impact what scanner we use and what information we need to capture at a finer level of detail. Knowing that, it can affect the overall timing and fees to produce the level of detail. Understanding that will help facilitate a better relationship between you and your third-party laser scan surveyor drafter and modelers. And level of accuracy globally and more specifically is not only impacted by the type of scanner you may have used, but also conveying your level of importance with different accuracy in different places. Overall accuracy, room, millimeter, finer level of detail. That may help with judgment calls in drafting and modeling. And lastly, while the scanners are highly accurate, they are not perfect, but they are typically a much more efficient option that captures more accurate information more quickly than measuring by hand. In addition, some level of base verification on the part of the architect or engineer should always be considered to be included in your work, as the architect is ultimately responsible for your needs and understand their client needs the best. So now we've talked about collecting the data and the point clouds and the laser scanners. So let's talk a little bit about creating the actual plan. However, before we move forward, we're going to pause to do one more poll. Just go ahead and write your answers in the chat again. What software do you work in? Do you work in AutoCAD and plan to only or always work in AutoCAD? AutoCAD, but you're looking at doing something in 3D or some other 2D software? Revit, ArchiCAD, SketchUp, and if it's other, just go ahead and type the other in the chat as well. Revit, ArchiCAD, ArchiCAD, quite a few ArchiCAD and Revit, makes sense. AutoCAD and stay in AutoCAD, CAD. Okay, all right, so there's a good mix, but a lot of 3D, a lot of Revit, a lot of ArchiCAD. So that's good to know. We work with a lot of ArchiCAD and Revit clients and AutoCAD clients across the board. All right, so now let's, now that we understand a little bit more, let's go ahead and dive into the drafting from the point cloud. When drafting from a point cloud, the first thing you'll need to do is get into a drawing environment. This can be imported directly into AutoCAD or Revit, as well as other architectural software. If you use Autodesk products, you'll need to use an application called Recap to prepare the point cloud to ensure it works within their entire software suite. Drafting from a point cloud in CAD is pretty straightforward, but it does take some getting used to. There are lots of options in CAD to color, slice, crop, move, and rotate the cloud in different ways. And you'll need to use the view cube to regularly adjust your UCS orientation to properly work within the cloud in different positions. Point clouds are ideal as-built data sets for creating Revit models, but the Revit point cloud tools can feel a bit lacking. If you're making a 3D model, it only makes sense to work from a 3D point cloud to create an accurate model to kick off your designs and planning. The tools for visualizing the point cloud are not as robust as they are in AutoCAD, and that's a little weird, but nevertheless, point clouds and Revit do go hand in hand. In the image here, we can see this is an example of a slice of a point cloud in plan view. And regardless of how you get your survey measurements, it's good to start any as-built by starting with the floor plan. When drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally so that you can use your ortho function in CAD to easily draw lines. If you're going to work on elevations or need to extract any heights from the point cloud, it's also good to position the point cloud in the z-axis. Typically, we start by lining up the finished floor surface of the first floor at 0, 0. And once you have the point cloud well positioned to begin drafting, you should be able to derive all the walls, doors, and door swings, and any other visible architectural and structural information right from the point cloud. Some items, though, like windows, can pose some difficulties when trying to extract width and height information, but with some diligence and practice at manipulating the point cloud, it gets a bit easier. Some scanners will not pick up smaller items, especially if they are flush with the walls or ceilings, primarily the mobile scanners. Trying to locate them in the cloud can be very time consuming. In that case, it's often better to use more traditional measurement tools while in the field and just sketch and measure those items. All right, so now let's talk a little bit about drafting other views such as an elevation from the point cloud. When working in a 2D drafting environment, it's not only important to have your point cloud well oriented in the drafting space, but you'll need to be well practiced at manipulating the coordinate system, views, and the point cloud sections. Once you do, you'll see that this is where there is a huge advantage in having a complete point cloud for drafting. Provided that you are able to access the roof in scanning, you will have a complete picture of not only the roof behavior, but also every height you'll need to properly draft your roof, exterior elevations, and any section you might need. As with electrical and reflected ceiling plan components, sometimes it's beneficial to revert back to the traditional methods to sketch elevation ornamentation items you'd like to include in your drafting. All right, so now that we've seen how we set up the point cloud in AutoCAD for drafting, let's also look at how this setup works in Revit. The level of development system was created for the AEC community to put standards on BIM drawings. It describes the different ways in which 3D objects can represent existing or design elements in a BIM model. With level 100, the lowest level, meaning you just mass your objects roughly, and level 500, the highest, being so detailed and exact you are essentially building a virtual version of the structure. When modeling as-built plans, LOD 200 is the most applicable range, since you are assessing a structure that has been built from the outside, with many interstitial spaces being inaccessible. The specific construction of many architectural and structural elements cannot be determined then, which is required for LOD 300 and above models. Similar to drafting in AutoCAD, the first thing you need to do to work with a point cloud in Revit is make sure it is in a recap project format. So you can use it with the other Autodesk products like Revit. Using the point cloud to guide modeling in 3D can be more complex than drafting in 2D. However, the benefits of having all the elements of a building related to each other in a set of 3D drawings can be really valuable to your design and planning process, because you can see the way things interact with each other in a way that you can't in a set of 2D drawings. Viewing the point cloud and model in 3D provides even more information about how structure, MEP systems, and architecture interact, more than you would find with a model alone. Modeling an as-built in Revit may seem overwhelming at first, but a solid order of operations for creating a usable Revit model will go a long way. So let's talk about a few things that you need to do before you start your modeling to make sure you can put the best foot forward. First, we can talk about modeling the plan view items from a cloud in Revit. When modeling in Revit from a point cloud, you'll want to ensure that your cloud is positioned orthogonally, just like in CAD in plan view, so that you can use the ortho function to place the walls. Then set the finished floor to your 0, 0 level, and then create and set all other levels to key features in the point cloud, other levels, plenum, top of roof, etc. And once you're done setting the finished floor, you can then start adjusting your view range and view depths in your plan views to add wall, door, and window families in the places indicated by the point cloud. As with AutoCAD, this is where there is a huge advantage in having a complete point cloud for modeling. Drawing sections and adjusting section depth is crucial to viewing point clouds effectively when adjusting those window heights, door heights, and creating roofs. And practice patience. Roofs are tough to model, but even more so when you want them to accurately match a point cloud. So there are some advantages to having a BIM as built, which some may not know. Sometimes a three-dimensional model is only considered for a presentation for design purposes, but it can also be useful as an as-built as well. The as-built BIM model can be viewed in multiple phases, so you can easily switch between the existing or as-built level, demo, proposed, and alternate proposed phases. And when you have a BIM model, moving from the design phase to the construction documents phase of a project is far more efficient. And having an as-built BIM model can make it easier to understand a project that you haven't visited yourself, since you can cut sections, view interior spaces, and review roof massing all in 3D. Some say Revit offers a more intuitive design experience and allows users to present 3D images at the planning stages to owners and the planning department. All right, this is our third and final poll before we get into the Q&A. What is the most important factor to you when generating your as-built plans? Is it A, quality and accuracy, B, timeliness and turnaround time, C, efficiency, or D, cost? A, C, all of the above, A. So mostly quality, a little bit of efficiency and cost. All right. Well, I mean, then laser scanning might be the way for a lot of you, because it does improve the levels of quality and accuracy. It's more efficient, and we typically see with our clients that it costs less than, excuse me, costs less than having to return to the site multiple times throughout the design process to continue to capture information. All right, so my question to you is, as we start the Q&A section, you all probably have your own questions, but I'm gonna feed a couple to you to start with. How often do you require as-built plans before you start working on a project? Also, what is the most challenging part of developing the as-built plans, assuming you're doing it yourself?
Justin, would you like them to just put that in the chat, or do you want them to unmute and ask the question?
They can do either that they prefer. If they prefer to type in chat, I can answer them that way. If they prefer to actually ask it and have a conversation, that's perfectly fine too. Okay, so I always try to get them before planning and design. Zach, is that a question about getting into areas behind existing drop ceilings or concealed spaces?
No, sorry, that was a, I think you asked about what are the tricky, issues
Oh,
about
gotcha,
generating as-built. So that's always a thing. And
gotcha.
I think this
Yep.
laser scanning technology obviously is great because you could hold it up in there and, scan a structure usually or something that we have a little harder time doing without exposing everything. So
True. I will say that even with the mobile scanners, getting above a dropped ceiling, especially if there's a lot of things above a dropped ceiling, it still requires removing, strategically removing ceiling tiles to make sure that we can get it up there and get some range. Oftentimes we run into ducts just like you would by hand that are right to the bottom, or one ceiling tile over or whatnot. But yes, that is tricky. I think that's tricky across the board. But definitely it's a little easier with the laser scanner at times. So there's quite a few of you that always require it. Thank you for the questions and the comments, everybody, by the way. How do you deal with untrue as-built conditions? Can you elaborate on that question?
Sure. Cricket walls, out of line columns, that type of
Oh,
thing.
gotcha. We have a tolerance for how we do it, but we also look to you as the architect to provide what you prefer. So our standard is 1 to 2 inches over 10 feet. If it's more misaligned than that, we typically draw it as skewed or angled. But if it's less than that, we default to kind of finding the average and making it orthogonal, splitting the difference potentially, or looking at the cues in the scan. But we also know that sometimes it's critical to have it actually shown as angled or skewed even when it's less than 1 to 2 inches over 10 feet. So we would look to you to give us that guidance to determine if it's necessary. On the flip side, I would also say that sometimes it's perceived that things are straight and they end up being skewed, bowed, angled, sagging, and whatnot. And so again, what is the most critical thing in understanding expectations? Because we can do it either way. It gets to be a little challenging to do it as skewed at times, but the cloud allows us to do that a little easier. Hopefully that answers your question, James.
Yeah, thanks. Thank
Yep.
you very much.
You're welcome. Almost always need as-built drawings. Most difficult thing is the assumptions needed to make our models workable, determining consistent heights, true construction methods, centering. Yeah, and honestly, I kind of referred to it in the level of detail section and which scanner, but I mean that's a tough thing for us too. When you're as a third party, we're trying to utilize our couple decades of experiences and what we find is most often needed, but we can't read minds. So while we like to think that we represent the majority of the architects that we work with, which I think we do, it's really helpful to have an understanding of what your assumptions might be or what you prefer as far as I mentioned, the point cloud thicknesses can get to be half or an inch thick, depending on how much data is built up in an area. And so, the center line is usually where we go to, but sometimes the inner parts of those is more true to the dimensions of the room. So there are a lot of assumptions and judgment calls that have to be made, which is, I think, probably one of the challenges that AI has in converting point clouds to models and drawings. I really appreciate all the comments and questions so far. Are there other questions or comments anybody has? Yeah, go ahead.
Can you talk more about how AI is coming to play in this?
Yes, James. My knowledge of it is a little bit limited, but what I know is that it's still in development. Even what we do with Recap and other softwares has a small degree of AI in it. And the challenges again are the judgment calls and setting the parameters for the computer to what it needs to learn and what it needs to assume. And so I think it's going to be a while yet before AI is able to take point cloud data and essentially automatically convert it because of all those factors, right? Like, do you want each of these decisions made based on a set of parameters? If this, then this. And so those are the challenges that I understand that they're going with. Right now, it's limited to, in this environment, it's pretty limited. I think they can do some limited like floor plan information, but when it starts to get into 3-dimensional properties, it starts to get, I think, bogged down and confused.
Who owns the document you're creating? With that said, and can it be transformed into an AI situation? If you follow me, and uploaded to a building, for example, or a house that you modeled, can that be uploaded to an AI situation or just in
Yeah.
general?
Yeah, the point clouds right now, I'm not aware of any software that fully takes it and does a whole lot with it. I know that it's still fairly in its infancy. I don't know of any that exists to any of us as consumers that can do really anything with it. Right now, it's pretty much still fairly manual because you still have to and I don't even know the names of it. I'm not in that realm of our work. We have a couple of people that are deeper in the laser scanning technology side, but I do know that they're still working with figuring out getting past, when it comes across those situations, what it needs to do. So there's still a lot of, basically most of it's still manual right now. So if I understood your question, I think I answered it, but I know it's not as much information as you probably were hoping to have. Any other questions about the laser scanners, the process, working with the third party, level of detail, challenges?
Here's another question in the chat, Justin, from Lisa.
Okay. Oh, typical cost of services. Well, I mean, we can put our website on there. We have some typical ranges for single family residential. Commercial gets a little more complex, but we do have some pricing on our commercial page on our website as well. Like I said, it ranges greatly depending on whether it's AutoCAD or 3D BIM ranges. I think most of our base pricing on our website for single family is based on AutoCAD. But you're looking at, for floor plans, roof plan, exterior elevations, which is the majority of what our clients need. In AutoCAD, we range for that package of drawings, range from between 70 cents to $1.40 a square foot. And for Revit, we're on average 15 to 25% more than that, depending on a lot of factors, square footage, complexity, number of stories, level of detail. There's a lot of factors that go into what the pricing might be. So, we try to give a range on our website, but I find the best way to get a sense is if you have a project that's typical for you, reach out to us for a pricing, and we'll price it and we'll see where we come in and can talk about, what the differences are in scope and fee to get where you might want to be.
Justin, I want to jump in and say that right before that question, the same individual, Lisa, asked a couple other questions.
Okay.
And then we have one more from his Sal, and then that's probably all we have time for. I want to make sure we show the last slide as well as your contact information in the raffle. I will say also that I'm putting information about our DC area services in the chat, as well as our residential pricing that Justin was mentioning.
Thank you, Amber. So let's see, once the model information is collected, is the drawing process the same as if the information was collected with more traditional methods? I mean, it's a little different with sketching by hand. You're drafting lines, offsetting them, drafting based on those dimensions, and then placing windows and things like that. Revit, you're creating walls and other elements. Similarly, you're creating a starting point and going around the perimeter, starting with the perimeter. So some of the processes are the same, but the efficiency at which you can do it is different. If you remember, maybe I can actually just go back to it, but if you remember from the floor plan slide here in AutoCAD, you can kind of see the walls over the point cloud here. And so, we have our perimeter measurements that we take as verifying measurements, and then, we're drawing everything else basically with some of those assumptions of and years of experience of working with point clouds of what we like to do and what our processes are. to draw those lines or model those walls over top of it. So it becomes way more efficient to do it over a point cloud than to, you know, work your way through a sketch on a sketchboard next to you while you're trying to, you know, run your lines around AutoCAD. So your next question is their ability for automatic conversion of anything into the 3D BIM environment. That's kind of what I was referring to with AI. It's not quite there yet. I think there's a lot of us that would like to see that, but it's just not there yet. It's still pretty much manual. Thank you for those questions. When measuring, how do you deal with heavily furnished, messy interior spaces that you measure around furniture, et cetera? So by hand, same way as probably, you know, we've all been doing in the architecture industry for a long time. Either, you know, move it, get behind it, you know, try to do that stuff. For the laser scanning, it's actually pretty straightforward. I've done some surveys myself. My team has done some surveys that have a lot of boxes, a lot of stuff, a lot of furniture, a lot of things on the walls. As long as we have a couple of good spaces where we can get the wall, the ceiling, the corners, the transitions, as long as we have some of those and have the edges of the windows and take some hand measurements to the windows, we can get some pretty darn good information from a fairly limited or from a fairly messy property, if you will. Not to say that we like doing messy properties. We always still prefer an empty one, as I'm sure you do as well, but it makes it a lot easier with the scanner for sure. Was there another one I missed, Amber, or was that it?
That was it, and I think that's a great time, since we have 1 minute
Okay.
left, to show.
Yep, I'm gonna go to the very last slide here. Thank you.
And I'll put your contact information in the chat as well.
Yep. So I want to thank all of you again for attending. I do truly hope that you are all able to gain some insight and perhaps I'll get a chance to work with even more of you in the future or to collaborate with you. For over 21 years, PPM has been delivering pretty high quality, if not the highest quality, as-built surveys to architects like all of you across the country. Our time-tested processes, cutting-edge technologies, and gold standard of service provide you with a smooth and reliable as-built surveying experience. Lastly, Amber from our marketing team will be in touch with our random raffle winner sometime in the next week. So good luck to everyone on that. And thank you, Amber, for putting my contact information in there. If you have not already or you joined late, if you would like AIA CEUs for this, please put your AIA number and name and information in the chat now, or you have my email address. And Amber, do you want them to put, do you want to put yours in there too, in case they want to just send it to you that way?
I'll put mine in there, and let me clarify that Pam wrote in the chat that as long as you registered through her AIA PV link, which I believe everyone did, then she already has that information. If somehow you found this webinar not registering via that link, then please send your information. And yes, I'll put mine as well if you have any questions about the raffle or anything else. Thank you, everyone.
Awesome. Thank you all. I really appreciate you taking the time to join this webinar with us.